Welcome students to Darasa Online. We have another session of chemistry. Your teacher is Mr. Kenneth Kaunda. Now in the last session, for those who are present that day when we were discussing, we introduced the topic of matter. Now we said matter had got three subtopics which we looked at last time, but now we still have another subtopic of matter, which is elements and symbols. At the same time, you have got compounds and mixtures. Now today we'll be looking at elements and their symbols. Now I do believe at the end of the day, we'll have to discuss a number of items that are related to elements. At the same time, their symbols. A number of times, questions that come in terms of elements and their symbols, normally students miss to get those questions because they either don't know how to write the symbols of particular elements, in which case they cannot be able to write good formulas, and also gives them a hard time to write chemical reaction equations. Now, I do believe at the end of this discussion, we shall be able to write good symbols, good formulas, and then in the future, we'll be able to write exactly correct chemical equations. Let's discuss together and see how far we can be able to reach. Now, students, our topic is matter, and our subtopics are elements and symbols. At the same time, we have got compounds and mixtures. Now, we are going to start with elements and symbols, and later on, we'll go to compounds and mixtures depending on time. I would like us to discuss together, and please, let's try to be concentrating on what we're going to discuss. I'll be giving you ideas, trying to explain items, and then I'll be writing short notes that we can be able to take and revise later on. Now, students, let's discuss what are elements or what are symbols. We cannot have a symbol before we know what an element is, because the symbol we're talking about is the element, the symbol of the element. Now, what is an element? Now, when we're discussing matter last time, we agreed that matter is any substance you're seeing around. Now, any substance we said consists of a particular type of matter. Can be one type of matter or different types of matter. And remember, we said that this matter consists of particular items, the composition of matter. And we said matter consists of elements, or consists of compounds, or consists of mixtures. Now, the first section, we are going to look at this composition of matter, which is elements. Now, what are elements? Elements are small particles that cannot be split into simpler substances by any chemical means. That if you take it, you cannot be able to split it. Either chemically, you cannot be able to split it. Now, we said elements consist of atoms. Now, when we talk about elements in terms of reactions, it's only the atoms that are contained in the element that do react. Now, how do the atoms react? Atoms react by either losing or gaining electrons. Now, when we talk about matter, in the composition of matter also previously, we said matter consists of simple, tiny particles. Now, these particles are electrons, are atoms, and also are ions. Now, when matter reacts, we talk about the elements reacting. When elements react, we talk about the atoms of those elements that are reacting. Now, how do the atoms react? By either gaining or losing electrons. Now, when we talk about elements, then we can talk about their reactivity. Now, based on their reactivity, you can have different classes of matter. Now, matter is classified into elements, compounds, and mixtures. Now, the elements are also classified into different types, metals and nonmetals. How? Based on their kind of reactivity. Those particular elements that react by gaining electrons are called nonmetals, and those particular elements that react by losing electrons, they are called metals. So the act of losing or gaining electrons can give us an idea on how we can be able to classify the elements. So elements are small substances that cannot be split into simpler substances by any chemical means, and they are divided, or they are into two classes. We have got the metals and also the non-metal. Now we've said this divisions is as a result of the reactivity of the elements. The classes are based on the reactivity of the atoms by gaining or losing electrons. So the classes are based on the reactivity of the atoms of the elements by gaining or losing electrons. Remember, I've said initially that the elements are divided into two, metals and nonmetals. Now the reactivity of the elements are dependent on the atom itself by either losing or gaining. So there's those kind of atoms that lose electrons, the nonmetals, and those atoms that gain electrons, which are called the metals. Later on in the course of study, we'll be able to differentiate between metals and nonmetals. But until now, we should know that metals lose electron during reactivity, and also nonmetals gains electron during reactivity. Now we'll have to look at some of the examples of these elements, because there are a number of elements. For example, you have had things, people talking about carbon, oxygen, things like nitrogen, things like sodium, things like chlorine. All these ones we're talking about are elements. Most probably, maybe you have not known them, but they are elements because we hear them each and every day as you walk around. You see them as you study, as you read. You also look at these elements, but you don't know what are they exactly. This is what we are going to look at. Now, let's now try to see some of the examples of these elements. So, students, can you tell us some of the examples of elements that you know? So, the common examples of elements that we know includes carbon, includes hydrogen, they include oxygen, they also includes sulfur, they also includes iron, etc. You can list as many as possible. Now, these elements, carbon, hydrogen, oxygen, sulfur, iron, etc., are the ones that you can be able to classify as metals and non-metals. Now, if you look at the ones that I've written, for example, carbon, hydrogen, oxygen, sulfur, iron, we can be able to group them into two classes. The ones that are metallic and the ones which are non-metallic. The metallic elements includes we have got sodium, we have got iron there, we have got aluminium, we have got potassium, we have got calcium, magnesium, etc. Calcium, sodium, we can talk about aluminium, we can talk about calcium, boron, etc. And the non-metallic elements includes sulfur, we can have phosphorus, we can also have oxygen, we can have fluorine, etc. Now we've looked at the examples of metallic elements and also non-metallic elements. Now what's remaining for us to do is look at some of the differences between metals and non-metals. Now students, if I may ask you a simple question. You've ever seen a metal and also you have ever seen a non-metal. For example, most of the experiments that we have been doing, we have been using sulfur, which is a non-metal, and also you can know a metallic element, for example, iron. Now, if somebody asks you about the difference between the two, at least I know you can be able to highlight a few. So let's try to enumerate a few of these examples of the differences between the metals and the non-metals. Now, metals are always solids. Metals are normally solids in nature. Non-metals are always gaseous in nature or liquids in nature. For example, the element bromine is liquid in nature. Most of the non-metals are gases. For example, we have got oxygen, fluorine, we have got chlorine, we have got all these other gases. They are gases. Now, the other difference between metals and non-metals, students, is that metals have got very high melting points and boiling points. Melting and boiling points. The non-metals have got very low melting points and boiling points. Now, the high melting point in metals is because of the high metallic bonding in the metals. The low melting and boiling points of non-metals is because of the low bonding structure in these particular compounds or these particular elements. Now, the third difference is that metals are malleable and also non-metals are non-malleable. Malleability, students, is the fact that metals can be drawn into sheets. Metal can be drawn into sheets. That means we can take a small piece of metal and then draw a sheet out of it. Non-metals, we cannot have that property. So the fourth difference is that metals are non-ductile. Metals are ductile and non-metals are non-ductile. Ductility and non-ductility is coming about because metals can be drawn into wires. For example, you have seen aluminum wires, you have seen copper wires. Those wires have been drawn from the metals. Non-metals themselves, we cannot draw them into wires. For example, if you have sulfur, we cannot draw wires from the sulfur. The other difference is on their conductivity of electricity. where we know metals conduct electricity. And nonmetals are always non-conductors. There are so many examples that you can be able to give on the differences. These are just but a few of them. You can also have a density. Normally metals are denser, non-metals are always less dense. There are a number of them. At your own free time as you read, you can also be able to add a good number of them. You can add as many as you can. Now students, let's try to look at some of the symbols of these elements. Now at least we know the elements, some of the examples, metallic elements and non-metallic elements. Now we can be able to use symbols to present these elements. Now let's try to look at the chemical symbols. Now students, what is a chemical symbol? Now a chemical symbol is just a representation of an element. I can write, for example, a letter X. If I write letter X, I know X represents a particular element. For example, I can say, let's try to use the letter C. If I write letter C, I know it is meant to mean carbon. Now here in Tanzania, if I see a letter C, I'll know it is carbon. If somebody goes somewhere in Europe, if he sees the letter C, still he'll be able to know this letter C stands for carbon. It means that the symbols we are using for elements are internationally agreed symbols or letters. Now let's try to look at the definition of the word a symbol. Now a chemical symbol is a letter or two letters or abbreviation which are used to represent a particular element. Now in your course of study, you'll be writing chemical formulas, chemical equations. Now before you write an equation, you must be able to know how to write a formula. Before you write a formula, then you must be able to know how to write a chemical symbol to represent an element. So you cannot just say oxygen plus hydrogen gives us water. We expect you to write something like O plus H will give us H2O. Now writing those formulas represents giving us what? Giving us a good example of writing a chemical symbol. So they are internationally agreed and also are used worldwide. A letter or two letters represent a particular element or an abbreviation which is used to represent an element. Now let's try to look at some of the rules that we use in trying to write chemical symbols. Rule number one says a chemical symbol, we can be able to use the first letter of an element in its capital nature. That means the first initial capital letter of an particular element can be used to represent that particular element. For example, if you say carbon, then you can say the letter C represents carbon. Or if you say sulfur, you use the letter S, then you can say S represents the element of sulfur. Or you can say O represent the element of oxygen. So the first letter of any particular element can be used to represent that element when you write it in capital letters. For example, we can say carbon, represented by the letter C. Or we can say sulfur, represented by the letter capital S. Or we can say hydrogen, represented by the capital letter H. Or you can say boron, represented by the letter capital B. So we use the capital letter of the first letter of each element to present that particular element. Now this one, the C, the S, the H, and the B, we call them chemical symbols of these particular elements respectively. Now, as we go along looking at this, writing these chemical symbols, sometimes we come with complications. For example, there may be 2 or 3 elements which have got the same starting letter. In which case, if you use the first letter, the capital letter, to represent that element, then sometimes you can look ambiguous because you're going to get confused. For example, if I have something like cobalt. Cobalt starts with C. Carbon starts with C. Now, if I read the first letter of C, somebody might not know whether I'm talking about cobalt or I'm talking about carbon. Now, in which case, we have to sort the ambiguity by looking at the second rule. Now, I would like us to take a look at the first rule and the symbols. Then I give you a brief idea of how we get the second rule. I want to give you some elements, then I see how we can be able to write their symbols. So let's, for example, have this element called cobalt. Let's also have an element called silicon. And let's also have an element called helium, or an element called beryllium. Now, if you look at these elements properly, and then look at the first rule, then automatically their symbols will be C, S, H, and B. Beryllium is B. Now, I would like you to look at these symbols using the first rule and look at these symbols of these elements. So this carbon C, cobalt C, sulfur S, silicon S, hydrogen H, and helium H. So in this kind of scenario, then it will bring a confusion. So if I write a C, somebody might not know I'm talking about carbon, or might not know I'm talking about cobalt. So that brings us the second rule that will be able to differentiate so that I don't write C and C. So let's look at the second rule. So the rule says the symbol of an element can be taken as the first initial capital of the element together with the second letter in the name. But the second letter is supposed to be in small letters. So if I have these elements, for example, I have my cobalt, I also have my silicon, I also have helium, and then I also have beryllium. Then based on this rule, cobalt will be CO, the first initial is capital, and the second letter, small letter. So I have my CO as cobalt. Then I have my Si as silicon. I have my He as helium. I also have my Be as beryllium. Now, by doing this, we solve the case of confusion that might arise using the first rule if they have the same first initial capital letter. Now in this case, so in this case, the anomaly that could arise by two elements having the same symbol is solved. Let's look at rule number 3. Students, rule number 3 says that the symbol of an element can be also the first initial capital of a element and any other letter in the name, which is in a lowercase. For example, we can have an element like, let's say, zinc. Now, if you use the first rule, the symbol would be Z. If you use the second rule, the symbol would be ZI. But it might not be the first or the second rule. So we have a third rule where the name can start with the same initial capital Z and any other letter in the name in a lowercase. So in this case, zinc becomes Zn. You can also have a situation whereby you can have a symbol, an element like chlorine, which is just Cl. It's not the first and the second. We can also have something like magnesium, which is Mg. So it's the first capital letter and another letter which is not the second letter. So in this case, we can also have a rule which describes the symbol of elements as such. So let's put the rule down. The symbol of an element can be the first initial capital of the element and any other letter in the name written in lowercase. We have given examples of magnesium, we've given examples of zinc, we also given examples of chlorine, etc. Let's look at number 4. Now, in your studies, you'll agree with me that some of these elements in their names, they have retained their Latin names. A good number of metals, their names originate from the Latin name. So they were changed to English from the Latin. But when writing symbols, some of the elements retain their Latin names. So they get the symbol of those elements from their Latin names. For example, we can have an element like sodium. Sodium is English name. The Latin name is natrium. So when we get the symbols of these elements like sodium and the rest, then instead of using the English name to get their symbols, then we use their Latin name to get their symbols. In which case, there are a number of metals. Rule number 4. For example, let's say potassium. Potassium, the real name in Latin is called kalium. And if it's kalium, then the symbol becomes K, the first initial of the name. We have something like sodium. Latin name is natrium. And the symbol is Na. We have an element like copper, whose Latin name is cuprum. And then the initial becomes Cu. We also have an element, for example, iron, whose Latin name is ferrum. Then the symbol becomes Fe. Another example is lead, which is plumbum. And the symbol is Pb. You say, etc. So a good number of metals, if you've noticed, most of them are metals which have retained their Latin names. So at your own time, try to get as many metals as possible which have retained their Latin names and the symbols are derived from Latin names, and try to fill up the gaps that you have left. These are just a few. So based on these symbols of the elements, I do believe you will not find any difficulty in trying to write correct formulas of particular compounds. For example, somebody tells you the compound is, let's say, sodium oxide. So if you say sodium oxide, it means a combination of sodium and oxygen. So we can have my sodium and my oxygen. So we combine the two to get the correct formula. So students, we are through with these elements and chemical symbols. I do believe that through discussion that we have reached so far, you can be able to handle any question that's about an element and also writing the chemical symbols of these particular elements. With a lot of practice at your own time, you'll be very much perfect in trying to understand this concept. Now let's go forward and look at compounds and mixtures. A compound and mixtures. Students, last session when we talked about matter, we introduced the topic of matter, we talked about the composition of matter. We said that matter exactly is a substance. So substance consists of matter. And then we also said that a pure substance may be either elements, mixtures, or compounds. So when we talk about compounds and mixtures, we have an idea exactly what they are. Now today, in this session, we would like to see exactly what's the difference between these compounds and mixtures, how do they come about, and what are they all about. So let's start by defining what they are. Now, I do believe all of us know what a mixture is, because if you are told to mix two things together, you take 1 and 2, bring them together, you are mixing the two. Now, in the process of mixing the two, either something can happen or not happen. Those two can mix and you cannot separate them again. But those two can also mix and yet you can also separate them again. So when we talk about compounds and mixtures, there's a very big difference between the two. Let's take, for example, you add maize and beans together without boiling. So you put maize and beans together, at your own time you can also separate maize and beans physically by just picking. Now that one is a mixture, because what you started with maize and beans, you can end up with maize and beans again after mixing them. But if somebody tells you now to combine, let's say for example, to combine sodium and oxygen. Now you combine sodium and oxygen, there's no way out you can separate the sodium and oxygen again. There we say some kind of reaction has taken place. So in which case, for us to know a compound or mixture, there must be some determinant factors. Now let's try to look at these factors that can give us an opportunity to test whether a particular substance is a compound or it is a mixture. But let's start by defining what compounds are and what mixtures are with their examples. So we say a mixture is a substance consisting of two substances not chemically combined. A compound is a substance consisting of two or more substances which are chemically combined. So there's that word chemically combined and chemically not combined. That's the only difference between the two scenarios. Consisting of two or more substances not chemically combined. For example, an example of a mixture. We can have a mixture of iron and sulfur. We can also have a mixture of, let's say, maize and beans. We can also have a mixture of ethanol and water. We can also have a mixture of salt and water, etc. It means that salt and water, we put them together, we can be able to derive the salt from the water again. If you have ethanol and water, we can be able to separate the ethanol and water again to get the components separately. Maize and beans, like I've said before, you can be able to sort them out by hand picking, so you can be able to separate the two. Iron and sulfur, mix them together, we can be able to separate the two by using a magnet. I do believe you all know that iron is attracted by a magnet. So if you mix iron and sulfur, sulfur does not respond to a magnet. Iron responds to a magnet. So the two mixed together, you can use a magnet and separate the two. So all these things, because you can go back to the original components that you had before, then we say these ones are all mixtures. In which case, what we're doing here, there's no chemical reaction taking place when you bring the two together. Now let's try to look at the scenario of compounds. So a compound is a substance consisting of two or more substances which are chemically combined together. So we talk about chemically combined together. What does it mean? It means that when the two come together, there's no way we can be able to separate the two again. So if we combine X and Y, and we cannot be able to get X and Y again separately, that kind of scenario is a compound. So you'll have a compound of X and Y because we cannot reverse the process. Now, there are a number of examples of compounds which even you know. A good example is water. So students, if you have water, what is water made of? Water is a combination of hydrogen and oxygen. Now, when you bring hydrogen and oxygen together, you get your water. But there's no way you can be able to separate hydrogen from oxygen again to get them separately. So in which case, what has happened here is a chemical change. So we say hydrogen and oxygen has been chemically combined together to give us water. Another example is common salt, which is a mixture of sodium and chlorine. The common salt we are using at home for cooking is sodium chloride. So we have mixed, or we have combined sodium and chlorine together. Now when you combine sodium and chlorine together, the process is not reversible. It means you cannot get sodium separately and chlorine separately. Those two are called a compound. Now, another example is maybe sugar, which is a combination of carbon, hydrogen, and oxygen. This is also a compound. It means that when you have sugar, you cannot remove the carbon, hydrogen, or oxygen and get the components separately. So it is a compound. Now, if you know what a compound is and what a mixture is with their examples, then you can go a little bit further to exactly know what exactly is a mixture and a compound. So let's look at types of mixtures. Students, we have got two types of mixtures. We have got homogeneous mixtures and also heterogeneous mixtures. Now, what do they mean? Homogeneous means you get two things and put them together, then you cannot see the difference between the two. For example, if you take ethanol and put it in water, they are miscible liquids. Now, when you put them together, you cannot see the difference between the two. That's called homogeneous mixture. Now, heterogeneous mixture is when you put two things together, but still you can be able to see the components separately. For example, if you have got immiscible liquids, like you put paraffin into water, the paraffin, because less dense, will float in the water. So when you put it in water, you'll see the upper layer is paraffin, the lower layer is water. That means it is heterogeneous. At the same time, if you take, for example, chalk powder, you take a chalk, grind it into powder, put it into water, then you'll see, because they don't dissolve in each other, even if you stir, but you'll see a good number of particles floating around in the water. That means it is not uniform. That is called heterogeneous mixture. So homogeneous mixture in which there is complete mixing of two substances, e.g. solution of salt and water. When you put salt into water, you cannot see the difference. You cannot see the salt inside. That is homogeneous in nature. Now, heterogeneous it is a non-uniform for example, immiscible liquids, for example, a suspension of chalk in water, etc. That means it is not uniform. You can see both particles together, both two, the water, the chalk powder, you can see them. Immiscible liquids, you can see the two liquids on top of one another. That's called heterogeneous mixture. Now, let's look at this homogeneous mixture. Then we'll get the difference between homogeneous and also suspension. In homogeneous mixture, we have said it's a mixture where there's uniformity. And to give an example of a solution of salt in water, or you can say ethanol and water. Now, if you have a solution, the word solution has got two connotations. A solution consists of two things. A solution consists of a solute and a solvent. A solute is the one that dissolves in a solvent, and the solvent is the part that does the dissolution. So if we have a solution of salt and water, then in that solution we have the solute, which is the salt, dissolving in the solvent, which is water. So sometimes you are asked questions, you're given particular solutions, homogeneous solutions, then you are asked what is the solvent and what is the solute. So you are supposed to know that a solute is that particular solid substance that dissolves in the solvent, or a solvent is that particular component that dissolves the solute. So we have solute is the one that dissolves in a solvent. And the solvent is the substance that dissolves the solute. So we can have a solution is equals to a solute plus a solvent, and it is uniform. It is uniform. So we have got a suspension, not uniform, and then you have got a solution which is uniform. So sometimes you are asked a question, differentiate between a solution and a suspension. Suspension settles down on standing, and also suspension, because they are not dissolved completely, you can be able to separate by filtration. And also in suspension, the components moves around in the mixture. So if you get two components, one suspension and one is a solution, then you can be able to know which one is which. Look at how they are. If the one which is very much clear and homogeneous is a solution, the one that you can see components moving around in the mixture is called a suspension. Now let's look at a brief summary of the difference between compounds and mixtures. So students, from the discussion about the characteristics of mixtures and also of compounds, we are able to give some differences between compounds and mixtures. We can be able to enumerate them, but we just write a few. We can be able to use the idea of separation. When one can be separated physically, then cannot be separated. We can also be able to use the fact of energy. When a compound is formed, energy is used, but we can also use the idea of composition. In the mixtures, the composition of a mixture remains the same. We can have an uniform composition, but in compounds, the composition has to be very fixed because it is very much uniform. So we can enumerate them. Number one, let's talk about separation. The components cannot be separated physically. In this one, the components can be physically separated. In this one, energy is involved. In this one, no energy is involved. Number three, the composition is fixed. This is non-uniform composition. You can mix them or combine them in any way you want. And here, number four, properties of each component is different. From the original, and here the properties are an average. Of the properties. So students, we can have these four differences between these two components, compounds and mixtures. So students, this one brings us to the end of this lesson today, the difference between mixtures and compounds. Now we're going to take a very short break, and when I come back, we look at some of the questions and how to answer some questions. Okay students, welcome again to Darasa Online. We have just finished the session and now we are back to look at some of the questions. Now let's see our question number one. Question number one says, magnesium chloride has a melting point of 714 degrees centigrade. Two samples A and B of magnesium chloride were found to have melting points of 713 to 716 degrees centigrade and 714 to 715 degrees centigrade respectively. Which of the two samples is pure and why? Now students, from our discussion, this question is talking about purity of a particular substance. Now when we talk about purity of a particular substance, students, we are talking about the range of boiling points and a range of melting points. If a substance is very pure, then it can boil or can melt at a very small temperature difference. So if you look at this difference of 713, 716, a difference of 3 degrees centigrade. If you look at this difference of 714, 715, a difference of 1 degree centigrade. Now from the two values, then we expect that the one with a very small difference, which is 714, 715, is exactly a pure substance. So when you talk about sample A of 3 degree difference and sample B of 1 degree difference, then this question of pure sample is sample B, because the temperature difference is very, very small. There's less impurity. I hope you have understood, students. Question 2 is saying a beaker A contains a mixture of chalk powder, calcium carbonate and water, while beaker B contains a mixture of ethanol and water. What are the three differences between these mixtures? Now, chalk powder and water from our discussion are insoluble. That means from suspension. Ethanol and water from our discussion forms a uniform mixture, solution. So this question is talking about the difference between a solution and a suspension, which I do believe you have discussed and you can be able to handle. Question 3 says calcium carbonate and added copper 2 sulfate were both heated, which had a change in mass, and explain your answer. It's talking about change. Calcium carbonate, when you heat it, it produces carbon dioxide. When you heat copper sulfate, it will produce water vapor, but you can still cool the water vapor to go back to the copper sulfate. So it means when you talk about the changes that takes place, then automatically this one will be a physical change, and the calcium carbonate will be a chemical permanent change, because we are releasing carbon dioxide, mass decreases. Now we have got some other questions, 4, 5, which I can be able to leave for you as an assignment. I think you can be able to note them down and read. Let's have question number 5. What is a compound and not a mixture? Support this statement using 4 arguments. The question was asks you to give the characteristics of a compound. Question number 6. Question number 6 talking about symbols, and we are talking about similarity between the first letters of the elements. Try to handle it and see how far you can go. Now before I leave the session, I've got reference books here for you. If you can have them, you can be able to have a look at the topics you have done and also get the questions at the end of the topics. The first book is Certificate Chemistry by Holden and Lambert. The second one is Chemistry for Secondary Schools, Book 1 by TIE, Tanzania Institute of Education. The third book is Comprehensive Chemistry for Secondary Schools, Book 1 and Book 2 by Nyahori and Mahumbwe. These are 2 books. There's Book 1 and also Book 2. So if you check on these books and this particular topic that you have handled, then you're going to get a number of questions. Try as much as possible to solve those questions. I want to thank you for this session. Welcome again. Next time we have a session like this. Enjoy yourselves.